2.4b, multiples of integers. So in the next couple of lectures, we will review material that will allow us to add fractions with different denominators. So last lecture we saw that to add fractions with the same denominator, we only need to add the numerators but keep the denominator the same. So in these next couple of lectures, we hope to answer the question, what happens if the denominators are not the same? What if we're working with different sized pieces? So we start by looking at multiples of integers. A multiple of an integer is an integer is that integer multiplied by some whole number. So the multiples of 2 would be 2, 4, 6, 8, 10, 12, and so on. So let's go through an example. Find the first 3 multiples of 12. So clearly 12 times 1. 1 is a whole number, so 12 is a multiple of 12. That counts. 12 times 2 is 24. That's another multiple of 12. And 12 times 3 is 36, which is also a multiple of 12. So these are the first 3 multiples of 12. 12, 24, 36. So another example, real-world situation. List the 5 smallest amounts that you can withdraw from an ATM that dispenses in increments of $20. So you might actually come into this situation. So clearly, the smallest amount we can take from an ATM that dispenses 20s is $20, which is 20 times 1. The next smallest we can withdraw is 20 times 2, which is equal to 40. 20 times 3, 20 times 4, and 20 times 5. Let's compute these. This is 60, this is 80, and this is 100. So these are all the 5 smallest increments that we can withdraw from an ATM that dispenses 20s. And they're just the multiples of 20.